because the 4 detectors of Bob are not balanced. They have different blinding power. They have different breakdown voltage. So for this simple control diagram, we only get nearly 100%, but not 100% control efficiency. So if you can see this matrix, each column represents that if send a certain fixed state, which detector of Bob has got a click. So at the diagonal elements, they are not 100%. They are from 96% to 99%. And the more important thing is that there is an error that the other detector has got a click. This is not very good. And what we want is to increase the diagonal elements to 100% and eliminate the off-diagonal elements. So the solution is that to introduce a pre-pulse before the main pulse. The pre-pulse is aligned at the polarization state opposite to the main pulse. So this main pre-pulse will blind the other 3 detectors deeper and make them harder to get a click. So therefore, the target detector will be relatively easier to get a click. So by improve this control diagram, we get 100% in the diagonal and there's no off-diagonal elements. So of course, to implement these pre-pulses, we need another 4 laser dials. So we improve our final scheme. So finally, the fixed generator of Eve totally has 9 laser dials. So far we have done this experiment in lab. And then we want to do the experiment outdoor. We moved to the campus of National University of Singapore. We have found 4 buildings. We laid 290 meters of fiber through the 4 buildings. And at one end of the fiber, in the building of the Center of Quantum Technologies, we place our Alice. At another end, in the office of physical department, we place our Bob. And down there, the transmission line goes through the mechanical department. On the picture, you can see that Alice contains the EPR source, the blue light, and the detection unit. And the Bob contains the detection unit and the timestamp card. And by this, we have run the normal QKD experiment between Alice and Bob. We have do the communication between Alice and Bob, and we have recorded every experiment result. We have recorded every QKD parameters, such as key generation rates and quantum bits error rates. And after that, we disconnect the fiber at a certain point. We insert our Eve at this point. And if you can see on this picture, in this suitcase, this black things with a blue label is another detection unit, which is the copy of Bob. And the rest of the suitcase is the fixed generator to get the control of Bob. And this yellow fiber comes from Alice, and this fiber goes to Bob. And then we have also done the QKD experiment. We have also done the communication between Alice and Bob with eavesdropper. So after the experiment, Eve has got her private key the same as Bob. And the more important is that we compare the QKD parameters. All the parameters are the same as before the attack. Alice and Bob didn't notice the existence of Eve, so we have done a successful attack. So if we see some experiment result of, if we do the precise check of the Eve's clicks, so we have made a time cut of the clicks in Eve. This is a time period of about 10 milliseconds. Every blue dot represents a click at a certain detector at which time. So we compare it with clicks in Bob in the same time period. So for me, it looks this looks quite correlated. And if we superpose them together, and we can see that every blue dot is overlapped by the red dots. So that means if yeah, I will say it later. So every click in if has launched a click in Bob. So some of you has already noticed that. Also, this is a good correlation. So some of you has already noticed that this few click in if but not in Bob. But this is not a problem because after the transmission, Bob will review the timing information, and he will reveal at which time he has received a click. So by this information, if can throw out the clicks she has failed to launch on Bob. So after all, if has still get the 100% information of the keys of Bob. So all the clicks in Bob is a subset of clicks in if. So we have done several experimental runs. The longest run lasted over 8 minutes. In this 8 minutes, if has sent to Bob about 12 million bits, and most of them are successful launched a click in Bob. And if we compare the quickie parameter, the key generation rate is always kept at 25,000 per second, and the quantum bit error rate is kept at 6%, which is lower than the alarm limit. This is very important, and there's no noticeable change after Eve's interruption. So we can see that we have done the first implementation of an intercept-resend attack under realistic conditions. And thank you. And last thing is to compare the quickie parameter by plots. So you can see before and after attack, the key generation rates and the quantum bit error rates are both kept at the same level. So then I will do a short demo to show how to get a full control of a single channel in the real detection unit used for Bob. I will firstly to blind this channel and then to launch a single click at this channel. So the whole setup is here. If you cannot see it clearly, you can see the picture of the setup here. So here is the circuit of the fixed generator, and here is the pulse generator to drive the laser diodes. And here, this is a real detection unit used for Bob. And the output of the channel is connected to this counter and is already connected to the computer. You can see the counts of the here. The counts shows how many photons the detector has received per second. So now you can see it is sensitive to the background light. So if I cover it with a black cover, so the count has been decreased. So now if I power on a certain laser diode to keep it blind, oops. So it's not sensitive to any light. Even if I remove this black cover, it's not sensitive to any background light. So then, when I introduce the optical pulse, this is 10,000 optical pulse per second. Oops, you can see the detector responds at the same count rate, and even if I increase the optical pulse to 20,000, it will change at the